Question number 15. The diagram shows a circle center O that passes through A, B, C, and D. The tangents at A and B meet at D. ATB equals 62 degrees and DAB equals 53 degrees. Everything is shown on the diagram. We have to find angle X first. This right here, this is very simple. You see that this angle is being made by the arc BCD, and the same arc is making an angle on the circumference, and that angle is 53 degrees. So angle X would be twice 53 degrees. So 2 times 53 degrees. And the property that we are using here is actually that this is angle at center, and hence it will be twice. So the answer would be 106 degrees. We got our X figured. Next, find Y. So find Y angle is right here. This is what we have to figure out. Now for this one, if you see, this lies in a quadrilateral. The C point is on the circumference D, A, and B. This makes a cyclic quadrilateral. And what I'm looking at is A, B, C, D. This is a cyclic quadrilateral, and hence, and hence the opposite angles must be supplementary. So we can see that the opposite angle to Y is 53 degrees, as given. So if we take away 53 from 180 degrees, we would get angle Y. So Y degrees would be equals to 180 minus 53, that's 127 degrees, the answer. Next up, we have to find angle Z, that is right here. Now they have told us that AD, and we can see too that AD and PT, they are tangents. So tangents, because they're meeting at T, so they would be making an isosceles triangle, as this angle Z would be equals to this angle right here. This would also be Z degrees. So we are looking at, for C part, we are looking at triangle A, B, T. It's isosceles triangle. So angle Z would be equals to 180 degrees minus 62 degrees, because they are angles in a triangle, so angle sum of triangle. And by the way, I have to divide it with 2 because there are 2 Z angles. These 2 base angles, they are equal, hence I'm dividing that by 2. So 180 minus 62 divided by 2, we get the answer, that's 59 degrees. That would be your Z. Next, we have to find angle T. Angle T is right here, this bit only. Now, by the way, this OD and OB, they were radii, and BD was the tangent. So this complete angle technically should be 90 degrees, because this is the angle between radius and tangent. And out of this 90 degrees complete angle, that is what I'm saying is T plus C should be equals to 90 degrees. Why? Because they are because this is angle between radius and tangent. Keeping this in view, Z was already figured out in C part that this is 59 degrees. This means T would be equals to 90 degrees minus 59 degrees. So 90 minus 59, the answer is 31 degrees. That's your answer. Question number 16. Now A, B, and C are points of the circumference of a circle center O. O is the midpoint of BC and ABC equals 38 degrees. Tangents are drawn from D to touch the circle at A and B. We first have to find BCA and then ADB. So first of all, we see the center has been marked. So this BC would be the diameter because this is chord passing through the center, hence the diameter. And we know that whatever angle a diameter makes on the circumference, it's always the 90 degrees. So this angle right here would be the right angle, 90 degrees angle. So if you look at this A, B, and C, now it's a right angled triangle. So I'm looking at triangle A, B, C, or A part, because I have to figure out this angle. So two of the angles in this triangle are already known, so we have to just figure out the third angle. So 180 degrees, angle BCA would be equals to 180 degrees minus 90 degrees plus 38 degrees. The answer would be 52 degrees. So angle BCA is 52 degrees. Next, we have to figure out what is angle ATB, this angle right here. Now this AT and BT, these are tangents meeting at T. So this makes this triangle isosceles triangle. So triangle ATB is isosceles. So if only we had two of the, or we find two of the base angles, or one of the base angles actually, we would be able to figure out this angle T, because this angle would be equal to this angle right here. Now to figure out this one of these angles, if you notice this bit A till B, this is the radius, this line is the radius, and hence this whole angle would be 90 degrees because this is the angle between radius and tangent. So angle OBT would be 90 degrees. Why? Because it's angle between radius and tangent. So if I subtract 38 from 90, I would get this angle right here. So this means angle ABT would be equals to 90 minus 38 degrees. That would be 52 degrees. This means this is 52 degrees, and since base angles were equal, this would be 52 degrees as well. So now to work out ATB is pretty simple. We're looking at triangle ATB. So angle ATB would be equals to 180 degrees minus 52 minus 52. So 180 minus 52 minus 52, we get 76 degrees is our answer. That's it. In question number 17, it says in the diagram PQRS and T lie on the circle, QT is the diameter of the circle, center O, X is point of intersection of PS and QT, PXT equals 125 degrees and PSQ equals 35 degrees. A part, complete the following statement with a geometrical reason. PTQ equals 35 degrees because now PTQ, this angle they're saying this would be 35 degrees. Why? Because you see this angle is coming from the chord PQ and the same chord is making this angle 35 degrees that is, and hence these angles would be equal. So the reason is because these are angles made by same arc or same chord are equal, however you want to write it, whatever. Okay, PQT is what we have to find next. So PQ and T, this angle right here. So for finding this angle, first thing, this QT was a diameter because it was passing through the origin and was curved. So QT is a diameter, that means this angle right here, the angle that this diameter is making at the circumference would be 90 degrees. Now if you notice, this PQT is a right angle triangle. We already have 35 degrees figured in first part. Angle TPQ is 90 degrees. We figured that out right now, and hence we could be applying the angle sum of triangle and finding it. So this would be 180 degrees, take away 90, take away 35. So if we subtract 35 from 90, we get 55 degrees. So that's the answer. Next, we have to find SPQ. This is this angle right now. That they are talking about. Now, for finding this angle, there could be different strategies, different ways of looking at it. Now, first thing that we can all see very clearly is that this right here is 25 degrees. I'm looking at, so for C part, I'm doing the first method. It could be maybe another method as well, but these are the two methods that I can think of right now. So if you look at triangle PXQ, this right here is the 125 degrees. So I can find this angle easily because they both of these angles, they are lying on a straight line and hence must be supplementary angles. So if I subtract 125 from 180 degrees, I would get this angle right here. That would be 55 degrees. So let me just write down this. Wait, this is what I figured out in B part. Okay, so angle PXQ would be equals to 180 degrees minus 125 degrees. Why? Because they are angles on a straight line, and hence the answer is 55 degrees. Now if I look at triangle PXQ that I already wrote earlier, so no need to write again. Okay, so if I look at triangle PXQ, two angles are already known to me. This was 55, it looks like 56. Let's make it clear. Okay, two angles are already known to me. So the third angle, that is angle XPQ, could be equals to 180 degrees minus 55 minus 55. The answer would be 70 degrees. And this angle is basically the same angle that they are talking about, angle SP. You may refer it to angle SPQ. Same thing. So this is the first method, that you look at angle PXQ. Now I'm going to use the other method, the second method right here. Let's just change the color for that. For C part, second method. Okay. For that, I guess I should rather raise this working here, so it's more clear. All right. So now, if you're using the second method, what you could be doing is that this is 125 degrees given. This angle would also be 125 degrees. Why so? Because these are vertically opposite angles. So angle SXQ would be 125 degrees as well, because these are vertically opposite angles. Just to recap, vertically opposite angles, whenever you see an X forming or a cross forming, this and this angle would be equal. This right here would be equals to this angle right here. So these are vertically opposite angles. Okay, so now if you look at triangle SXQ, in that triangle you have two angles figured, angle S 35 degrees, angle X 125 degrees. So that means angle SQX would be equals to 180 degrees, take away 125 degrees, take away 35 degrees. So 180 take away 125, take away 35, you get 20 degrees. So this means this right here is 20 degrees. And in the earlier part, that is in B part, you already figured out that this bit is 55 degrees. So now if you look at triangle SPQ, this whole angle is 35 degrees. This whole angle, you can add them, that would be 75 degrees, and hence you can find angle P. So angle SPQ would be equals to angle SPQ would be equals to 180 degrees minus 35 degrees minus 75 degrees. How did I get 75? 20 plus 55. This whole angle is 75 degrees. Okay. And the property I'm using is angle sum of triangle. So what do I get? 180 minus 35 minus 75. I get 70 degrees again. So these are two different ways of finding angle SPQ. You may use whatever you think is easier to understand. Coming towards D part now. In D part, they are saying that you have to find angle SRQ. This angle SRQ is this. This is what I need to find out. Now, if you notice, this is on the circumference, this is on the circumference, this is on the circumference, this right here is on the circumference. So this is a cyclic quadrilateral that's forming. So for D part, I'm looking at PQRS is a cyclic quadrilateral. So hence opposite angles would be supplementary. So this angle and this angle right here, they should add up to 180 degrees. And this angle right here, angle SPQ, is what we already figured out in C part. So this is 70 degrees. So that means 180 degrees minus 70 degrees would give you angle SRQ. And the property that we are using is that they are opposite angles of a cyclic quadrilateral. So 180 minus 70 degrees is 110 degrees. So that's your answer of D part. And there you go. Question is complete. A, B, C, and D lie on circumference of a circle center O. AOB equals 120 degrees, ADB equals x degrees, OBD equals y degrees, and DAO equals 2y degrees. Find x giving a reason for your answer. All right, so we have to find x. So you see this x is on the circumference, it's coming from the chord AB. And the same chord is making one angle at the center, this right here, 120 degrees. So the angle at the circumference would be half this angle, 120 degrees. That means it would be 60 degrees. So x would be 60 degrees. Why? Because it's the angle at circumference is half the angle at center. Really sorry for such messy handwriting. I should rather erase it. But I hope you understand. And you can find the reason written right here as well in the answer. Okay. Next we have to work out DAB. Angle DAB. This is this complete angle right here. Right now we do see that DAB is a triangle. However, we have so many unknown stuff around here. So let's just figure out whatever stuff we can. So for instance, I need to know this angle first. I need to know this angle first, and that would actually give complete three angles to me on this triangle DAB. So working out this angle and this angle that I marked with green, I'm looking at triangle AOB. In this triangle, if you notice, this OA and OB, these are radii, so hence this is isosceles triangle. So this angle OAB and OBA, they would be equal. So angle OAB would be equals to angle OBA. Why? Because it's isosceles triangle. So this angle would be equals to 180 degrees, take away 120 degrees, and you divide that with 2. So 180 minus 120 degrees would be 60 degrees. 60 degrees divided by 2 would be 30 degrees, and hence your answer is 30 degrees. This means this is 30 degrees right here, this is 30 degrees right here. So we got both our missing angles figured out already. So if I, and x, by the way, I just calculated in the first part, this is 60 degrees. So now if I turn my attention to this whole triangle ABD, in this triangle now, one angle is 60 degrees, the other angle is, let's say this angle DAB is 2y degrees plus 30 degrees. Again, what am I talking about? I'm talking about this angle right here, because this was 2y, this was 30 degrees, so this complete angle would be 2y plus 30. Likewise, this is y degrees, this is 30 degrees, so this complete angle would be y plus 30 degrees. And when I add all of these together, I should get 180 degrees. The reason being that this is angle sum of triangle. Okay, so let's just solve this equation. I get 60 degrees plus 2y plus 30 plus y plus 30. So I get 90 plus 30, 120 degrees. 180 equals 120 degrees plus 3y. So 180 minus 120 would give me 60 degrees equals 3y. So y would be equals to 60 divided by 3, 20 degrees. That means this is 20 degrees. And what we had to find was DAB, this complete angle here. And this complete angle was what? Angle DAB was actually 2y plus 30 degrees. So if I substitute the value of y right here, so it would be 2 times 20 plus 30 degrees, that would be 40 plus 30, hence the answer is 70 degrees. So 70 degrees is the answer. So much going on in here, but I hope you understand. Next up we have to find BCD angle. So this BCD is this angle right here. Okay, so we see this, 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 the 4 vertices lying on the circumference. So for this part, doing it like right here. So A, B, C, D is cyclic quadrilateral. whatever. Okay, it's cyclic quadrilateral. So this angle C and this whole angle A, they should add up to 180 degrees. This whole angle A is what you just figured out here, 70 degrees. So 180 degrees minus 70 degrees would give you angle BCD. What property I'm using here? These are opposite angles in a cyclic quadrilateral and hence should be equal. And hence should be supplementary. So when I subtract them, I get 110 degrees as the answer. So that's it. There you go. Question number 19. The diagram ABCD and E lie on circle center OBOE is a straight line DAB equals 34 degrees. We have to find x degrees. This is center right here. This and this would be the radii. I'm using gray color, which actually looks like part of the question. So let's just change this and this, they would be radii, and BE is a diameter, so this hole would be 90 degrees. Okay. Well, we have to find out what x would be, this angle right here. So if you notice, this angle x is coming from this arc BCD, this arc right here. Let's just figure out if this arc is making any other angle, and that too on the circumference. So this very arc is making this angle right here in the circumference. So and this very arc is making this angle here as well. That's lovely. Two angles being made by this arc BCD, or in other words coming from B and D point. So this is 34. This Z angle would be 34 degrees as well. This basically is the answer of C part, 34 degrees. Why? Because angles made by same arc. Okay, and this x degrees would be 2 times 34. Why? Because angle at center is twice angle at circumference, and hence the answer would be 68 degrees. Okay, next up we have to find y degrees. Y degrees is right here. It is actually at C. This C, this B, this D, this E, these 4 points, they lie on the circumference, and hence they make a cyclic quadrilateral. To make it more clear, I'm just erasing these lines. So this is a cyclic quadrilateral I'm talking about right here. This, and this quadrilateral. So ABCD is a cyclic quadrilateral, and hence this y degrees and this z degrees that we figured out is 34, they should be supplementary. So y degrees would be equals to 180 degrees minus 34 degrees. So 180 minus 34, the answer is 146 degrees. That's it. Okay, for D part, we have to find angle D. Angle D is right here. We already figured out that this would be 90 degrees. Why? Because this is the angle made on the circumference by the diameter. And a part of this angle, this 90 degrees angle, is given to be 34 degrees. So that's pretty simple. D degrees would be equals to 90 take away 34. So you get the answer, that would be 56 degrees. And there you go. Now question number 20. In the diagram, the points A, B, C, D and E lie on the circle center OAD is a diameter. So if AD is a diameter, by the way, this means this whole angle from here till here would be 90 degrees. And if this bit is 70 degrees, this means this bit would be 20 degrees. So I'm not really sure if that would be required anyway or not. I'm just writing it down, just the initial working. Okay, so DAC is 33 degrees, ACE equals 70 degrees. We have to find CDA first. CDA, this angle here. And that's pretty simple. We'll look at triangle ACD. We know this is 90 degrees. Why? Because this is the angle made by the diameter AD, and hence this is right angle. So we could apply for CDA. We can use angle sum of triangles. So 180 degrees, take away 90 degrees, take away 33. Alright, so the answer of this would be 57 degrees. Next up, we have to find angle DEC. DEC, this right here, this small bit. Okay, so for this, let's just see where this angle is coming from. So this angle is coming from the C and D point, this chord right here, or this arc, whatever. The same arc or the same chord is making this angle as well. So these two angles, therefore, would be equal because they are being made by the same arc. So this would be 33 degrees as well. So it will be 33 degrees. ABC, getting away from these lines made after so much effort. 33 degrees. Okay, now we have to work out ABC. For ABC, this angle, you notice this point right here, this point, this point, this point, they are all lying on the circumference. So what I'm looking at is that ABCD is a cyclic quadrilateral, and hence the opposite angles would be equal. This, by the way, we just worked out in A part that this would be 57 degrees. So this would be angle ABC would be equals to 180 degrees, take away 57 degrees. So the answer would be 123 degrees. Why? Because these are opposite angles of a cyclic quadrilateral. Find reflex EOA. Alright, so reflex EOA is this whole angle, because reflex angle is less than 360 degrees. Now in this whole angle, what we know without doing any calculation is that this is 180 degrees because this is a straight line. This is 180 degrees, the angle that I marked with red. However, I need to work out this bit so that I would be able to work out this complete angle that I marked with this blue color. Alright, so for this, notice one more thing here, that this OE and OD, these are the radii. Therefore, triangle OED is an isosceles triangle. And this means that this angle and this angle, they would be equal. The base angles would be equal. The angles are marked with blue. But to work out these base angles, I need to do more calculation. For that, what I could be doing is I'm now looking at triangle CED. I'm looking at this triangle. I'm looking at triangle CDE. In this triangle, this is 20 degrees, this is 33 degrees. I can work out this whole D angle. So angle CDE would be equals to 180 degrees minus 20 degrees minus 33 degrees. I applied angle segment of triangle. So 180 minus 20 minus 33. This is 127 degrees. So this complete is 127 degrees. And out of this 127 degrees, it is highlighted with green that this area, this bit is 57 degrees. So if I take away this 57 degrees from 127 degrees, what I would get is this lower part of it, the part that is inside the triangle OED or ODE, this bit. So now what I'm doing is that angle ODE would be equals to 127 degrees minus 57 degrees. So this would give me 70 degrees. And this, by the way, angle ODE is equals to angle OED. I mean this angle right here. They are both equal. Why? Because these are the base angles of this isosceles triangle. And hence they are both equal. So they are about 70 degrees. So now if I want to work out this portion of the angle, this bit, I can be applying the angle sum of triangle. So angle DOE would be 180 degrees minus 70 degrees minus 70 degrees. That means 180 degrees minus 140 degrees. That would give me 40 degrees. So this bit is 40 degrees. So the upper right portion was 180 degrees. This lower portion is 40 degrees. So if I am now interested in finding this complete angle, this whole reflex angle, this would be 180 plus 40 degrees. So this angle reflects EOA angle would be 180 degrees plus 40 degrees. I know there's like a lot going on here, but if you maybe try to pay keen attention to everything and maybe rewind, watch it again, watch the solution again, and I hope you would be able to understand. So that's the final answer. Question number 21. In diagram, the two circles intersect at P, this point right here, and Q, this point right here. The line AB is a tangent to the circles at A and B. AD and BC are diameters. BD intersects the larger circle at R. DBC equals 40 degrees. All of this information is shown on the diagrams as well. As you can see, it looks very complicated, but I bet that this is not this hard. It isn't really that hard. So first we have to find CPR. C, P, and R, this angle. So let's just go down and see where this angle is coming from. This angle is coming from this line. And this line right here, that's going all the way down to this point. So this C and R. So let's just see if this arc this arc CR is making any other angle on this circle. By the way, this is the biggest circle that we are talking about. So if you notice the same arc or the same points, they are making this angle as well. You see that? So these are being made by exact same points, same arc. And what arc was that? CR, this arc. And hence these angles would be equal. So if this is 40 degrees, this would be 40 degrees as well. So CPR would be 40 degrees. Why? Because these are angles subtended are made by same arc. That's that. Next, CQR is what we have to find. CQ and R. CQ and R would be, I'm just erasing these lines here so it becomes a little more clear. So CQ and R would be this angle. All right, now here if you see this point, this, this, and this. 1, 2, 3, 4 points. Actually, I've taken 5 points, so maybe I do not want to take P point. Okay, so what I've made now is a cyclic quadrilateral. This right here, all the way down here, all the way down here, and here. This makes a nice cyclic quadrilateral. So the opposite angles of cyclic quadrilaterals should be supplementary. So this and this, they should be supplementary angles. So that means CQR would be equals to 180 degrees minus 40 degrees is a cyclic quadrilateral, and hence the answer is 140 degrees. Next we have to find A, B, D. Again, I'm first tracing these lines. Okay, so sorry. ABD. This is what they're asking us to find. This angle. This is pretty simple. This AB is a tangent to this big circle. And in this big circle, if this is the center, this is the radius. And hence this would be the angle between the radius and the tangent. You see that? This is the circle right here. This. This is the radius. This is the tangent. And hence this would be 90 degrees. So from 90 degrees, this part is 40 degrees. You can work out the remaining part. And what would that be? 90 minus 40 degrees, you would get that part. So 90 degrees minus 40 degrees, that is 50 degrees would be the answer. Next, ADB is what we are interested in. ADB is all the way down here. Now again, this lies in this triangle. So I'm just looking at triangle ADB right here. And by the way, if you notice again, this was the center of the circle. This AB is a tangent, so this would be 90 degrees angle. This you already figured out is 50 degrees. So you can apply angle sum of triangle. So 180 degrees minus 90 degrees minus 50 degrees. Again, we apply the angle sum of triangle, and we are looking at triangle ABD, and hence the final answer we are getting is 40 degrees. That's it. So you see, it looked pretty complicated from the shape, but it wasn't really that hard. Okay, question number 22. AC is the diameter of circle center OBCD and OED are straight lines. AC equals 6 centimeter and CD equals 3 centimeter. BAC equals 34 degrees. Explain why BCA equals 56 degrees. By the way, this is the center. This means AC, this center. This means AC is a diameter, and hence this angle right here would be 90 degrees because this is the angle made at the circumference by the diameter. So if this is 90 degrees, they are talking about angle BCA. So we are looking at triangle ABC. So if I have to work out angle BCA, for that, first of all, let's say angle A is already given. So angle ABC we said would be 90 degrees. Why? Because it's angle made by a diameter. And therefore angle BCA, angle BCA would be equals to 180 degrees minus 90 degrees minus 34 degrees. So the answer would be 56 degrees. So this is the explanation of why this angle would be 56 degrees. This angle is 56 degrees because this right here is 90 degrees. Then we have to find COD. Okay. So COD is this angle right here. This is what we have to figure out. By the way, if you notice this whole AC is 6. So half of it, that means this is the radius and this is the radius, by the way. So half of it would be 3. So this would be 3 and this would be 3 as well. If you look at, because this, we have to find angle COD. So if we look at this triangle, second part, I'm looking at triangle COD. Do you see that this is also isosceles? This is also 3. As this angle and this angle, they would be both same. These would be base angles of this isosceles triangle. So triangle COD is isosceles triangle. And if we work out this angle right here, we would be able to work out these base angles as well. So this angle right here is actually can be easily found. This angle OCD can be easily found by subtracting 57 degrees from 180 degrees. And why am I doing this is because BCD is a straight line. So this is a straight line. So these are the angles on the straight line. So if this is 57 degrees, this would be 180 degrees minus 57 degrees. So this gives me 123 degrees. So I know this is 123 degrees. Now I'm looking at triangle COD, and in this triangle COD, angle COD would be equals to 180 degrees minus 123 degrees divided with 2. Why divided with 2? Because this is isosceles triangle, this right here is isosceles triangle, and the base angles would be same. Let me just highlight this isosceles triangle with a different color so it makes easier for you to look at things is right here. Make things more visible. This is isosceles triangle. This is 123 degrees, we just figured out. But this angle will be equals to this angle. That is why I'm dividing with 2. So 180 minus 123 is 57, and if I divide that by 2, I get 28.5 degrees. So COD is 28.5 degrees. Next, we have to find angle OCE. OCE, that angle. Okay, I'm just erasing the step again. Make things better. Okay, so what I have now is, I know that this angle, I have to find this angle, by the way, this angle. I know this and this, they are equal, so this makes isosceles triangle, hence this angle would be same as this angle. And this angle I already figured out is 28.5 degrees. I figured that out in second part. So these base angles would be equal. We could again apply the angle sum of triangle thing. So I'm looking at triangle OCE this time, and in this triangle, angle OCE would be equals to 180 degrees minus 28.5 degrees, and whatever the answer is, I'll be dividing it by 2 because it is isosceles triangle. And why is it isosceles triangle? Because these OE and OC are the radii of this triangle, sorry, this circle. So if I calculate the answer, I get 75.75 degrees. And this you can round to 75.8 degrees or 76 degrees, whatever. So this is your answer right here. In question number 23, they are saying in the diagram ABCD and E lie on circle center. OAC is diameter. So if this AC is diameter, that means the angle it's making on the circumference, that would be this angle, to be 90 degrees. And this OC would be the radius. And if this is the radius, and by the way, they are next saying the tangent of the circle at C meets the line AB. Now, this is the tangent that they are talking about, CD, this line. So the angle that this line is making with the radius, that's OC, this angle would be 90 degrees. So this whole is 90 degrees. Now, what they're telling us first to find, oh, by the way, they have given us ACB equals 62 degrees, can be seen here, ACD equals 70 degrees given as well. So we have to find x first. So this whole is 90 degrees. This bit is 62 degrees. We can easily work out x here. So x degrees would be equals to 90 degrees minus 62 degrees. And again, the reason why this is 90 is because this is angle between tangent and radius. Next is saying we have to work out y. Oh, by the way, the answer of this is 28 degrees. We have to work out y. That we change the color that we have been using. Okay, so we have to work out y right here. Let's just see where is this y angle coming from. Go down this line and we see that this is coming from A, and this line right here is coming from B. See if this chord AB is making any other angle on this, in this circle. So this is making this angle right here, that's 62 degrees as well. And since these two angles, y and the 62, they are coming from the same origin, AB, hence these angles should be equal. So y degree should be equals to 62 degrees. Why? Because these are angles made by same arc. Next up, we have to find the z angle. And z angle, let me just get rid of these extra lines I made. Okay, so this z angle is right here. This z angle now does not really lie in a triangle. It's not coming from one specific chord, so it's going to be hard to figure it out, but not really. Why? We already have figured out 62 degrees, and if you notice this E point, D point, C point, A point, they make a nice and neat cyclic quadrilateral. So A, C, D, E is a cyclic quadrilateral. So opposite angles should be supplementary. That means this whole angle and the 70 degrees, when they add up, that should be equals to 180 degrees. So to work out this z angle, what we could be doing is that 62 degrees plus z degrees plus 70 degrees is actually 180 degrees. So 62 plus 70 is 132. So z degrees is equals to 180 degrees minus 132 degrees. And if we find the answer out, that would be 48 degrees. So 48 degrees is the answer of Z, 60 degrees is the answer of Y, and 28 degrees is the answer of X. Mission solved. Alright, question number 24. PQRST are points in circumference of a circle. PQ equals QR. That's going to be shown on the diagram. PQR equals 118 degrees and QRS equals 99 degrees. We have to find PTS. PTS, this angle. And we have to show all our working. Now for PTS, as you can see very clearly, S, T, P, and R, they are points on the circumference, the cyclic quadrilateral thing. So what we could be using here, we would be actually. But for that, we need to know the opposite angle to T, and opposite angle to T would be this angle right here, which isn't known. We know this whole angle, 99 degrees, but we do not know this bit. So we first need to know what this bit, that is PRS, would be equals to. So we are first trying to find out that what this PRS angle would be equals to. So for that, first of all, let's use the isosceles triangle that's given here. Because what I have in my mind right now is if I figure out this angle and I subtract it from 99 degrees, I would get to know PRS. Pretty simple. So for figuring out this angle, I'm going to look at triangle PQR. Find that PQR, it's isosceles triangle, so base angles would be equal. This angle would be equals to this angle. So if I have to find angle PRQ or QRP, however you want to write it, PRQ, that would be equals to 180 degrees minus 118 degrees, and the answer would be divided with 2. Why? Because PQR is isosceles triangle, and this they have already told us. So 180 minus 118 is 62, and the answer when divided by 2 would be 31 degrees. That means this bit is 31 degrees. So my The main objective was basically to find angle PRS, this bit. So now this bit would be equals to 99 degrees minus 31 degrees. So answer would be 68 degrees. Now coming back to the real thing, that was PTS. For PTS, what I am going to do now is that for angle PTS, we know that PTSR is a cyclic quadrilateral. This means that angle BTS plus angle PRS would be equals to 180 degrees. If I have to find an angle PTS, what I could be doing is 180 degrees, take away 68 degrees. And the answer is 112 degrees. That's it. The entire solution.